How's it going? Let's talk about light on riding bikes and why it's so important. How's it going, Lone Riders? It's Andrew. I'm back with another video. What we do here is we talk about our product development and how we develop it, and we go through the whole stage from concept right through to production, make videos about it. So if you like that kind of stuff, hit that subscribe button down below and also that little bell icon as well. And let's just jump into it. So if you're a motorcycle rider and you've ridden at night, then you'll definitely know that it can get a bit hairy if you can't see. So everything is about visibility. And a lot of the bikes don't actually come with good OEM headlights. They just come with the standard. They pass the tests and that's it, move on. Even the top bikes are quite standard, better than other bikes, but even the top selling bikes are also quite average. So a lot of guys like putting on aftermarket lights. We're developing these lights, and we're going through the process of design, development, production, and we're at the stage now of looking at the light signature and how that light signature is important, and why it's important, and what people actually want from that. So I'll talk about that later, but let's jump into the computer and actually have a look about why it's important and what we're working on at the moment, and hopefully we can get your feedback and design it in as well. So the first image here is like from a YouTube video, Mob City Moto. He's shot a video. Thanks for we'll just take out clips from it. So, but the purpose is it shows you the light signature from different lights. So the first one is a GSA headlight, BMW R1250 headlight. OEM production line, no changes. This is what it looks like on just the drive beam, the normal beam. It works, but at low speeds. Then you've got the OEM additional headlights. So you can buy a package, and it gives you 2 extra ox lights on the side. And the purpose of these is to actually just illuminate left and right of you, so you can see some obstacle coming in from left or right. So that's the limit of these the factory bike with the upgrade. And then we go into the aftermarket driving lights, and you can see a massive difference. And a lot of guys feel much more confident riding at speed with this light, because it all has to do with reaction time and brake time and safety. So what would you rather have? This or this? It's pretty clear. We definitely want aftermarket lighting to illuminate the road in front of us and point out any obstacles. Okay, we could just blast away, just go full power and put different LEDs in. But what's really nice is we can actually control this light, and we can place it exactly where we want. And the purpose of this video is to ask you how and where you want these lights placed. So I'll go through it and show you. So light placement is important because you want to see the obstacles that you could possibly hit, and hitting it, no one wants to hit anything. So I made this little graph up here. We've got the obstacle that we don't want to hit, and then you've got the MOE, the margin of error. That's the human part, or any other part, natural part. And essentially what we've got here is you've first got to identify that it is a threat. That's you making a decision. Then once you've made that decision, you've got to react to it. So you've got to actually implement that action. So that means your brain has to tell your hand and your foot to give brake force. So that means also that reaction from this point when you're holding the handlebar up to over the brake and pull. And sometimes you can only use 2 fingers and stuff like this. So that's the reaction time. And the braking phase is when actually the brake pads are engaged and the bike is slowing down. And to do this, to identify this obstacle and to actually start this chain of events, you need to identify and see the obstacle. So a little graph down here, it gives you an example. So let's go to 60 miles per hour, which is about 100 kilometers per hour. You'll need a reaction time, then you'll need a braking time. So in total, that is almost 60 meters, 59.4 meters. That's the total time that you need to stop from the time you identify the obstacle and come to a standstill. If you take a bike, let's put that into the real world. The real world is, say, for an example, you're driving at 100 kilometers an hour and you need 60 meters to stop. And on the low beam of the GS, the visibility of the beam is 60 meters, exactly 60 meters, well, roughly 60 meters. So you will stop on that object. That's so with the low beam, driving at 100 kilometers per hour, you will stop on that object. So no one wants to get that close. And that doesn't mean maybe you're driving on wet roads, so you've got to think about that. The braking distance is going to be much longer, or non-sealed roads also. And also that object might be moving towards you. That's another possibility. So you've got to take off meters on that too. So it's also good to be seen. You want to be seen so they can avoid you as well. So that's it. So ideally, the key is to identify the object as quickly as possible, react to it, and stop safely in time or avoid it. That is the current. That's why we need to be able to light up the obstacle efficiently. So jumping into this project, we have to learn a lot about many things, and one of the things we have to discuss is the type of lighting with engineers and lighting designers, because we can design the light, the design of the actual cover and stuff like this, but we want professionals to develop the actual lens because we want the best optimal solution. And you'll be surprised that actually a lot of those lights out there that you guys drive with are simply working lights. I'll give you an example. I was working with my lighting engineer, optics engineer, and I showed him a light that was quite popular, and his reaction was straight away, that's a working light lens. And I was I knew it was because I know where it comes from, but it was quite shocking to me that so many people entrust brands. It's just not one, it's like many of them. And they are just essentially designed for a completely different purpose. So we really want to focus on the light and how it's used properly, and also to improve safety and driver fatigue and all this kind of stuff. So there's a lot to learn about light, and it's huge. It's a huge subject and super important. So essentially, the human eye only sees a small part of the wavelengths, light wavelengths, and it goes from X-rays right through to long radio waves. So the spectrum is huge, but the human eye only sees a small part, and within that, there's a whole spectrum of light or colors that we call colors that we see. So we always also have to consider that and place our mark on what we want to see also, because it affects a lot of environmental factors as well. So what we're looking at is so there's a playoff right here. Like the more blue we go, the harder it is to define form, and the more amber we go, it's harder to actually see, the distance is just not there. So we are looking to look around the neutral white phase, not completely white, because that just makes you tired, and it can increase fatigue. And there's also the option for an amber. Like amber is essentially selective yellow. Amber is an industry term, but selective yellow is actually the color that most of the driving lights you see out there and all the rigs are based on. So we're going to look at doing two colors, and we'll ask you guys that in the questions down below, what actually you want, because there's pros and cons to each of them. So for the pros, for the white color, it provides a wider and more even beam pattern. It gives you a bit more visibility and length, and it's better in clearer conditions. So the cons of white color, it's more scattered by the atmosphere particles, and it may cause glare on rain. So if you're driving in the rain, what will happen is that light will reflect off the rain particle and back into your eyes, and it'll make it harder to see. And as I said before, it's got more blue in it, and blue in it makes you fatigue. You can see that on your phone, for example. You could probably turn on blue light blocker after a certain time in the evening, and that's because what it does is they want to block the blue light, and it increases fatigue, this blue light. We look at screens all day, and it makes you tired. So that's the white color. The pros of amber is that you actually see, you're more visible for a start. You're more visible by other people. That's why we will come to that in a minute with our headlight guard. It penetrates fog, rain, and snow much better. That's why when you go skiing, you can put these amber lenses on, and you can see the contours of the white snow. It's less scattered by the atmospheric particles. So this is the Kelvin temperature that we're looking at doing, and we're probably looking at a neutral white between 4 and 5,000 K, and also for the amber, if you want an amber system, probably a 2,000 to 3,000. So to give an example, we did this with the headlight guard, and it pops you out. So if you look around, go onto the road next time and check it out. Most lights or most light sources are white. When you see this orange coming, it just catches your eye. It makes it more appealing, or makes it more like, what is that? And your brain recognizes that, and it takes note, which is good for safety because people see you better. But on the left-hand side here, you've got fog and amber, and that is the fog up the top, the white one, and the lights are below that. So this is the top has white light, and the bottom has orange or amber light. So then it pierces straight through it. It gives you a good example. On the top right, you have clear and amber light. So this is a clear day with no fog, with an amber light. And then you have a clear day with a white light. So if you see the difference there, you've got much more reach with the white, but you've got less contour. It's much easier to see the ground and the everything with the amber up close. I was just giving an idea why most people use amber and clear. So that with the light spectrum as well, we've got there's a lot of situations, so we have to figure out which is the best, and hopefully with your feedback we can really fine tune it, because we have a basic understanding of where we want to go with this. It's well documented, and the lighting optics engineer knows exactly what to do. But if we need to refine it just that level deeper, then we want to know what you want. So there's many different types of lights. There's a spot, there's a combination, there's 3 plus 10 watts, there's a floodlight, driving light, diffusion, and light scene light. So there's plenty of options, and we can combine these with limits to the wattage and also the amount of LEDs we can push into such a small place, because they can't be too big. It's on a motorcycle, but we can control that. So if what's important to you is a spotlight, and you'd like to see way out in the distance, let us know. If you'd like to see more of a floodlight or more of a diffusion light, so you like to see what's up close to you, or a combination between these ones, let us know. I'll leave a link in the description. But we can do that. What we can do with that is we can firstly decide on the right LEDs that we're going to use for that, and also we can fine tune the light signature, and that means the light signature means how we can control where the light goes out of that light emitting diode. And you can see here we can do 10 degrees, 20 degrees, the strip lights. We can even push it out wider with a 45 degrees or 60 degrees. And you see the TIR, total internal reflection lens here. It's like basically the LEDs here. It's bouncing back off the sides, and there's a bit of a waste here, but we can bring that back in. But yeah, that's essentially a cross section of like the lens that we can design. And what we can point this right up into where we want. If it's a spot, if it's a combination, if it's a close-up light, we can really control this light. And we've got simulations, and we can simulate all this. So yeah, this is the question: what do you want? So I've made a quick form here. You have to use your Google login because of spam. Sorry about that. But if you don't do it, then it just gets spammed. So the first thing here is just the naming conventions. What we're looking at. We're looking at driving beams. We're looking at off-road beam, which is kind of like the long distance. Fog beam was a bit shorter, and then the flood beam, which is trying to get best of both worlds. That's the fog and the driving beam. We can combine this as well. But the first question is the optimal low beam distance. So where is that point where you think at your speeds are the best to see? So that's the furthest point away up to that. So if it's 40 meters, 50 meters, you want to see at your speed driving, how far out do you want to see on a normal with your lights on low beam? Second one is the same question, but high beam, optimal high beam distance. So how far out do you want to see on the high beam? And you can say forever, but there's a limit to this technology, so we can't say forever. But what's the optimal there? It's up to 40 meters, up to 800 to 1,000 meters. It's possible, but it's not practical. Is it practical? Tell us. I don't know. I'd be interested to hear your feedback. Fog, optimal fog beam distance is at 5. Are you just riding slow over rocks and stuff like this in towns, and potholes everywhere, or the gutters that have big gaping holes that you need to navigate around, so you need to look down? What is it that you need? How far out is your optimal beam range for that? How much off the sides of the road do you actually want to see? So this is important if you've got deer coming in or other cars coming in. with their lights off, cyclists without bikes, without lights, things like this. So this question is more like when the road ends, from the edge of the road, how far out do you actually want to see? I mean, you can say maximum 30 and stuff like this, but if you really think about it, we can narrow it down to the optimal meterage. Also, what colors do you want? So if you're going to buy a set, what would you buy? Would you buy it off the shelf as an amber color, like a selective yellow, or would you buy a clear, like a white, off the shelf, or both, or would you prefer to have a kind of like a mixture between them and a cap that goes on top of them, or change out the lens, or some other way of doing it? And the last question is what we should know. Tell us what, in your experiences, what has been a lifesaver, the best feature, the optimal pattern that you've used, the optimal color, all that kind of stuff. I'd love to hear it. We'll go through this and read every answer. So yeah, that's it this week. Subscribe if you like that video, and there's more to come. We'll try and pump them out a couple of times a month and keep you updated with the products. We're going a bit slow at the moment because with the videos, because we're at a stage that we are developing the top box. Right now we're doing the DFM, the manufacturing part of that, and there's a lot to work around, doing the molds and tooling, investing in all that stuff. It's a lot of work doing the documentation and naming conventions, everything. This is the hard grind. So that's taking up a lot of time. There's nothing really much to talk about. And also we're doing these lights as well. So we've got that, but heaps of products coming up soon. We're going to crank soon. We've got a big list of cool products, really interesting products to make, and love to hear your feedback on that. So yep, subscribe and take it easy. For listening. Catch you soon.